In this video, we discuss evaluating and comparing algebraic expressions, and this is lesson 9 in your book. The types of expressions that we'll deal with are numeric expressions, which are just numbers and operations, and algebraic expressions. And these contain variables and numbers, usually, that use operations such as addition, subtraction, multiplication, and division. Algebraic expressions are sometimes called variable expressions because they contain variables. When we evaluate an algebraic expression, we start by being given values that the variable stands for, and we plug those values in the expression every time we see the variable. Then we follow the order of operations. Here we have an example, and this is one that you're going to want to write in your notes. We need to evaluate the expression when x equals 3 and a equals 1. See, we're given the values that the variables stand for. Now we need to plug these values in everywhere we see that variable in the expression, and then we can use order of operations to simplify. So everywhere I see an x, I'm going to plug in 3, and everywhere I see an a, I'm going to plug in 1. So I'm going to rewrite my expression, but with numbers instead of those variables. So I start out with 3, and it's times x, and I know x is equal to 3. Then there's a minus 4, and 4 is times x. Again, x is equal to 3. Minus a is equal to 1, times x, which is 3. Once all my values are numerical, I can use the order of operations to simplify. So I start with my grouping symbols. Here all my parentheses are just holding those numbers. There's no operations. Then I go to exponents. There's no exponents here either. Then I do multiplication and division from left to right. So 3 times 3 is 9, minus 4 times 3 is 12, minus 1 times 3, which is 3. Finally, I do addition and subtraction from left to right. So 9 minus 12 is negative 3. And then I've got that minus 3 I've got to bring down. And negative 3 minus 3 is negative 6. So our solution here is negative 6. Again, when we want to simplify expressions, we just plug in the numbers that the variables are equal to into the expression and then solve using order of operations. Here we have another example, another one you're going to want to write down in your book. Evaluate the expression for y equals 2 and z equals 4. And here's our expression. It's a little more complicated because there are exponents and operations and parentheses involved, but we do the problem the same way. Everywhere we see a y, we're going to plug in 2, and everywhere we see a z, we're going to plug in 4. And then we're going to use order of operations to simplify. So we'll rewrite our expression, 3 and then our parentheses. Here there's a z, and I know z is equal to 4. So instead of z, I'm going to write 4. Minus y, I know y is equal to 2, so I'm going to plug in 2 right there. And there's my exponent, minus 4. And 4 is times y to the third, and I know y is 2, so it's 2 to the third. Now we go through the order of operations. We start with our grouping symbols. This is just holding the 2, but over here we have 4 minus 2, so that's the first thing we're going to simplify. 4 minus 2 is 2. And then minus 4 times 2 to the third. Okay, now parentheses are done, so we move on to exponents. This 3 doesn't have any exponent, but 2 is squared, and 2 squared is 2 times 2, which is 4. Minus 4, no exponent on the 4. Here is 2 to the third power. That's 2 times 2 times 2, which is 8. Now my exponents are done, so I go on to multiplication and division. 3 times 4 is 12. Minus 4 times 8 is 32. And 12 minus 32 is negative 20. So our solution here is negative 20. Just like last time, we plugged in numerical values for the variables and then used order of operations. Here we want to compare some algebraic expressions when a equals 4 and b equals 3, and we're going to use less than, greater than, or equal to. Before we can compare them, we have to find out what numerical value they're equal to. So we need to simplify this expression and simplify this expression, and then find out which one's bigger, which one's smaller, or are they equal. So everywhere I see an A, I'm going to plug in 4, and everywhere I see a B, I'm going to plug in 3. So on the left side, I've got 3 times A, which is 4, squared, plus 2 times B, which is 3, minus 4 times B, which again is 3 cubed. Now to simplify the left side, we'll do order of operations, parentheses first, no operations in the parentheses here, exponents second, so no exponent on the 3, but 4 is squared, so that gets us 16, 4 times 4 is 16, plus 2 times 3, no exponents there, minus 4, no exponents on the 4, but 3 is cubed, so 3 times 3 times 3 is 27. Exponents are done, so we'll do multiplication and division. 3 times 16 is 48, plus 2 times 3 is 6, minus 4 times 27, and 4 times 27 is 108. And we'll do addition and subtraction from left to right. 48 plus 6 is 54. Bring down our minus 108. And 54 minus 108 is negative 54. Now we've simplified the left side. Now we want to simplify this right side and see how it compares to negative 54. So on the right side, we've got 2. A squared, and we know A is equal to 4, so we'll replace that there, times B squared, and B is equal to 3. Again, order of operations, no operations inside either of parentheses here, so we move on to exponents. No exponent on the 2. 4 is squared, 4 times 4 is 16. And then 3 is squared, 3 times 3 is 9. Now we'll do multiplication and division from left to right. So we've got 2 times 16, which is 32. And 32 times 9 is 288. Now the problem was asking us to compare these two numbers using less than, greater than, or equal to. So since negative 54 is less than 288, we're going to use the less than symbol. Negative 54 is less than 288. Finally, we have a phone bill example. Again, another one you're going to need to write down, as well as that comparing on the last slide. A cell phone company charges a $20 monthly fee and then 45 cents per minute. The company uses the expression 20 plus 0.45 m to find the total amount to charge for each month. How much would the company charge for 200 minutes? All right, so we have an expression here, 20 plus 0.5 m. Now this expression makes sense for cost because for every minute you pay 45 cents. So 45 cents times the number of minutes. And no matter how many minutes you use, you'll pay that $20 monthly fee. So that's why that's added on there. Now, we want to know how much the company would charge for 200 minutes. So here's our expression. And since they tell us that the company, or that we're wanting to know how much the company would charge for 200 minutes, M is our number of minutes, and that is 200. So we want to plug 200 into this expression for M and solve. We've got 20 plus 0.45, and then we're going to replace M with 200 minutes. Now we'll use order of operations to complete this problem. So parentheses are only holding a value here. There's no operations, no exponents, so then we move on to multiplication and division. 20 plus 0.45 times 200 gets us 90. That would be $90. And 20 plus 90 is 110. So how much would the company charge for 200 minutes? They would charge you $110.